We're going to take a look at question number 41 from section 8.5, graphs of nonlinear functions. So the function from 41 is f of x is equal to negative, and this is the quantity, x minus 2 squared, and then we are also subtracting 3 from it. Okay, so first off, ask yourself what the shape is, and the shape should have some sort of parabola shape to it, because this is a squaring function. Okay, that is noted straight away from the 2 in your exponent. From here, we would also want to start noting what's going on with our values. So I have a minus 3. Recall that if you are adding or subtracting a number outside of the function, in other words, is it following after the square or the cube or the absolute value, depending on what your problem has posed, we have a vertical shift. Okay, so we have a vertical shift. And also recall that the vertical shift is going to tell you the truth. So you can take a look at that negative 3 and you can tell me if it's going to move up or down straight away. So since it's a negative 3, I'm going to move down 3 units. From here, we would also want to note that we have a minus 2 on the inside of the function. Okay. Recall that if we add or subtract a value on the inside of the function, we have a horizontal shift. But then also recall that if it's happening on the inside, it's lying to us in terms of the direction that we want to take it. So think of it in terms of a house of lies or something like that. So a negative 2 then means that I'm actually going to go to the right 2 units. The last bit of information that we should note here is this minus sign that is hanging out in front of the function. That is telling us straight away that we are going to have a reflection over the x-axis. So the minus means a reflection over the x-axis. So that means that our shape is going to slightly change. It's going to point down this time. Our parabola is going to kind of frown in a sense. So from here, what I would suggest doing is we will set up a table, and we're going to start off with a straight out f of x is equal to negative x squared. So I'm going to take that negative into account right away. Okay. So let's go ahead and set up our table. And we did do this before, so you can refer to your notes that we did in class. So we'll start with a negative 2, negative 1, 0, 1, and 2. And in order to fill out these values, I would suggest you pause the video and fill these out for yourself. Fill out the table completely, and then come back. Okay, so just to double check to make sure that you've done the evaluation for your y values correctly, we use our function notation and we plug in a negative 2. So recall that the left-hand side, when you have f of negative 2, these are instructions. So it's telling you that everywhere that you saw an x in the function, replace it with a negative 2. Then we do our order of operations. So with this, I don't have anything to clean up in the parentheses since I just have a negative 2. So I move on to doing the exponent. So negative 2 squared will be a positive 4. But then that negative 1 is going to multiply with that positive 4 to give me negative 4. And then if we continue, this is negative 1, 0, negative 1, and then negative 4. Now we can spend a little bit of time and start talking about how we're going to move. So if I'm moving down 3, recall that that means that I am going to be moving along the y-axis because the y-axis is vertical. In other words, we move up and down it. So if I'm moving down 3, I'm going to subtract 3 from each of my y values. So now, just to be clear, it's not affecting the x-axis because the x-axis is a horizontal axis. So that is not affected until we move over to the horizontal shift because that's where we would be able to run along it. In this case, since I'm moving to the right 2 units, I'm going in the positive direction. Okay, Now we're going to go ahead and fill this part of the table out. And if you haven't done so already, please go ahead and pause the video and fill these out, and then come back and make sure that your solutions align with mine. Okay, so we get a 0 and then a -7. We get a 1 and a -4. So I'm just adding each one. So 0 plus 2 is 2, and 0 minus 3 is -3. 1 plus 2 is 3. -1 minus 3 is -4. 2 plus 2 is 4, and -4 minus 3 is -7. So now we have all the information that we need in order to graph this. So go ahead and write in or draw your y-axis and your x-axis. I'm going to go ahead and do 7 tick marks just to kind of keep everything nice and symmetrical. Or perhaps you're a little bit more prepared and you have a sheet of graph paper out in front of you. So now we'll go ahead and we will put these points in. So we have 0, 7, sorry, 0, -7, so that's going to be right here. 1, -4 will be right here. 2, -3 will be right here. 3, -4 will be right here. And then 4, -7 is right here. So we'll go ahead and we will connect those points. Look at our really ugly Christmas tree at this point. So you can kind of visually check to make sure that you did this all right. Did I have a parabolic shape? Yes, I do. And it's also pointing down. Again, that is because, and I'm going to highlight this in kind of like an orange, it's because of that negative that's hanging out in front of the function. Okay, so what you have outlined in pink is your solution. Please recall that if you just looked at the function for a parabola, that's going to start at the origin, so it would look something like this. This is a rough sketch, it's not perfect. But notice how the origin has traveled, or not the origin, how the vertex or the point where your parabola kind of sprouts from traveled. It went down 3 units and then to the right 2. So that automatically is checking off that you did the motions correctly. The fact now that your parabola is flipped over and is opening downward is because of the minus or negative sign, so that's why that checks out. So again, your solution, I'll box it in this aqua color, is right here on your graph.